Hello guys, and welcome back to our YouTube channel. In this video, we are going to be solving equation under inverses of functions. Okay, so here's the question. We have been given f of x as 5 on x minus 2, g of x as x minus 2 on 5, and h of x as 5 on x plus 2. So we have been asked to show that g is not an inverse of f and f and h are inverses of each other. Okay, so let's start. Let's start with the solution. Okay, let's take the first question, that is to show that g is not an inverse of f. Okay, to show that g of x is not an inverse of f, we need to look for the composition f of g of x, and we need to show that this composition is not equal to x. So that is what we are to prove. So if we were to prove if g is an inverse of f, then we would look for this composition and prove that it is equal to x. So that is it. But here we have the reverse. So we need to find the composition, that is f of g of x, and we need to see whether the composition is equal to x or not in order to prove. Okay, so let's start. So f of g of x the same as f of g of x. Okay, so this is the same as f of, what is our g of x? X minus 2 on 5. So remember, we are substituting this with x in our f of x function. So here we have 5 on x minus 2 on 5 minus 2. Okay, so now we need to simplify this. So we have x minus 2 on 5 minus 2. So let's take the denominator first. So let's take the denominator, x minus 2 on 5 minus 2. Let's look for its LCM. The LCM is 5. So we have x minus 2 minus 10. So this will give us x minus 12 on 5. Minus 12, that is minus 12, minus 2, sorry, minus 10, which is minus 12. So from here we put it back, that is 5 on x minus 12 on 5. Okay, so let me simplify this. This will just be 5 divided by x minus 12 on 5. So from here you have 5 times 5 on x minus 12. So if you want this sign to change, you replace it with a multiplication sign and you switch the numerator and the denominator. So now we're going to have 5 times 5, which is 25 on x minus 12. So as we can clearly see, this is not equal to x. So we have proved, we have shown that g is not an inverse of x. G is not an inverse of f of x. So our f of g of x is 25 on x minus 12, which is not equal to x. So we have it. So we can conclude, therefore, g of x is not an inverse of f. Yes. So we can say that. Okay, so that's it for the first question. So we have the second question. We need to show that f and h are inverses of each other. Okay, for f and h, in this case too, for f and h to be inverses of each other, their composites f of h of x should be equal to x, and h of f of x should also be equal to x. Remember, composition is not commutative. That means you can solve f of h of x, have an answer, and you solve h of f of x and have a different answer. That means they are not commutative. Okay, so let's take the first case, f of h of x, which is the same as f into h of x. So this is f. What is our h of x? It is 5 on x plus 2. So we substitute it into our f of x function. So we have 5 all on 5 on x plus 2 minus 2. So this is what we have. So we are going to simplify this and see if it will give us x. Okay, so let's have it. So we have 5 of x plus 2. We open the bracket minus 2. So this will give 0. So we have 5 on 5 on x. So this is the same as 5 divided by 5 divided by x. So this is also the same as 5 times x on 5. And as we can see, the 5's will cancel out and we are left with x. So our f of h of x is equal to x. But that's not all. Let's check the next case. Let's check for h of f of x. Let's see whether it will give us x. The same as h of f of x. Okay, so we do the same. This is h. Our f of x is 5 on x minus 2. So we substitute it into the function, that is 5 on 5 on x minus 2 plus 2. Okay, so that is what we have. So now we are going to try and simplify this. So if we tackle this, it will be 5 divided by 5 on x minus 2. That is all plus 2, and is the same as 5 times x minus 2 on 5 plus 2. Okay, so normally the 5's will cancel and we will be left with x minus 2 plus 2. So now let us open our bracket. So we have x minus 2 plus 2. So we can already see that this gives 0. So we are left with x. And that is it. So we have our h of f of x is also equal to x. So we have this, and from there we can conclude that f of x and h of x are inverses of each other. Okay, remember, To show that a function is not an inverse of another function, you need to test the composition of the two functions and see whether it gives you x. If it gives you x, then it is an inverse of the other function. If it is not x, then it is not an inverse of the function. And to test if two functions are inverses of each other, we need to test their compositions, like what we had here. We need to test and see whether they both equate to x. And if they both equate to x, then we can conclude that they are inverses of each other. Okay, so that is all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.